Graphing Problem 1. A position versus time graph is given below. Determine the velocity of the object from 0 to 2 seconds, 2 seconds to 5 seconds, and 5 seconds to 6 seconds. This is such a common problem in physics. You'll see graphs like this all the time and finding different things with them depending on what's on the axes. Now, what does position time graph mean? It means the position is on the y-axis. The first term that you say is your y-axis, and the second one will be on your x-axis. So it's going to be position on top, time on the x-axis. So this might be a little funny, right? Because you're always used to having graphs. You have x here, you have y. Now that's math, and that's wonderful, and that's perfect. But now doing physics, we're going to call this x, position, and we'll call this t for time. Here's the key point we need to know to do these problems. When you have a position time graph, the velocity of the object is given by the slope of the line. So we can calculate the slope of each of these segments to determine the velocity during the time period. And what is slope? Rise over run. There's another definition for rise over run when we have a position time graph. It's the change in x over the change in time, right there. So let's do part A. From 0 to 2 seconds, the position increases by 4. Okay, the position goes up here all the way to 4, and the change in time goes to 2. So our velocity is the slope of that line, which is rise over run, which in this case is delta x over delta t. Yeah, I know you're probably used to seeing it as delta y over delta x, and that's math, that's good, but now we're using math to do physics problems. So our velocity will be 4 meters over 2 seconds, which is 2 meters per second. So the velocity of the object is 2 meters per second from 0 to 2 seconds. Part B, from 2 seconds to 5 seconds. Looking at the graph from 2 to 5, the position does not change. Right, here's the position. You stay at 4 meters the whole time. The change in time is 3 seconds. Right, you go from 2, 3, 4, 5. 2, 3. Why do I have all the extra dots here? Okay, 1 second, 2 second, 3 seconds. Okay. So the velocity will be the slope, rise over run, which is also delta x over delta t. And we have the rise is 0. So we have 0 meters over 3 minus, well, and that equals 0 meters per second. So the velocity is 0. That should make sense because horizontal lines have no slope or a 0 slope, so the object has no velocity. Its position is not changing. Now we want to go from 5 seconds to 6 seconds. So that's this point here to this point here. The position moves from 4 meters back to the origin. So the change is negative 4 meters, right? The final position is going to be 0 minus the initial 4. So that's minus 4 meters. So we're moving back to where we started from. The change in time is 1 second. So we have velocity is equal to the slope, which is rise over run, which is delta x over delta t. Delta x is negative 4, t is 1, time's always going to be positive, so we have negative 4 meters per second. Our slope is negative, so the velocity is negative. The object is moving backwards towards the origin.